Supreetha, welcome to my math class. So in the previous lectures on limits, we studied about the concept of limits. Yes, we solved some JEE mains problem, and then in the previous lectures, we studied about we solved some JEE Advanced problems, right? So in the last video lecture, we solved the first two problems. Yes, that is this one and the first and second, right? So now let us try solving the third one and check if it is equal to 1. Okay, so I've already written the question. So let's start. So as you know, since we have tan x to the power tan 2x, firstly let me take y is equal to the given question, and then after applying log on both the sides, I would get log y is equal to limit x tending to pi by 2, okay, tan 2x into log of tan x. Okay, now after applying the limits, what would you get? What is tan pi? 0, right? What is tan pi by 2? Infinity, and log infinity is again infinity. So isn't this a type of indeterminate form? Yes. If you don't know what is an indeterminate form, please pause and get back to our previous videos. Okay, so since this is an indeterminate form and it is not in 0 by 0 or infinity by infinity forms, let me simplify whatever we have. That is limit x tending to pi by 2. We know that the reciprocal of tan x is cot x, right? So let me write it as log of tan x divided by cot 2x. Now what are we getting? So this is tan 90. Yeah, tan 90 is not defined. That is log infinity is again infinity divided by the same thing over here. This is also infinity. Yes. So since we are getting infinity by infinity form, let us apply L'Hospital's rule. Yes, what is L'Hospital's rule? Differentiate the numerator and then differentiate the denominator separately. Okay. So limit x tending to pi by 2. What is differentiation of log of tan x? I would get 1 divided by tan x into differentiation of tan x is secant square x divided by what is differentiation of cot x? We know that differentiation of cot x is minus cosecant x. Yes. Now let me write the minus sign. Yes, differentiation of cot x is, okay, it is cosecant square x, right? So it is cosecant square 2x. Okay, since we have 2x over here. Now what is the differentiation of 2x? It is 2. Yes. Now let us simplify our expression. Okay, so as we know, we can write tan x as sine by cos. Yes. What is the reciprocal of secant x? It is 1 divided by cos square x, right? Cos and cos gets cancelled. Divided by minus 2 divided by sine square of 2x. Yes, because reciprocal of cosecant x is sin x. Yes. So I would get limit x tending to pi by 2. Okay. So we would have sine square 2x divided by, we have a negative sign, we would have 2 sin x cos x. Now what is 2 sin x cos x? Isn't it sin 2x? Yes. So I can write this as pi by 2 minus sine square 2x divided by 2 sin x cos x is sin 2x. So I can cancel the numerator and the denominator. What is left? Limit x tending to pi by 2, negative sine 2x. Okay, so now I have sine pi, right? After applying the limits, I would get sine pi. So what is sine pi? 0, right? So on the LHS, I have log y. So now if we apply anti-log on both the sides, I would get y is equal to e to the power 0. So as we know, anything to the power 0 is 1. So our final answer is y is equal to 1. Yes? So the third value was B. So this is correct. Okay? So how did we solve this? Since we have tan x to the power tan 2x, we took y is equal to the given question and we applied log on both the sides. Yes, so as we know, log a to the power b is b log a. Okay, so we used that and we simplified the expression and found that there was an indeterminate form, that is 0 into infinity. Okay, so since we have 0 into infinity, we cannot apply L'Hospital's rule. We simplified the expression and brought it to infinity by infinity form. Yes, and then we applied L'Hospital's rule, and after some differentiation and simple simplification, we arrived at log y is equal to 0. Now, after applying anti-log on both the sides, yes, we arrived at y is equal to 1 because anything to the power 0 is 1. Yes, that is it for today's class. Thank you.